Okay, so the reason that we need to discuss, or we need to understand the concept of covariance is because we use it to calculate correlation. Correlation is what we'll probably use at the end of the day to communicate our results and really to make comparisons between different features in our data set and really understand the strength of each of those relationships. So what we do is we take covariance, we look here at the bottom, take covariance, we divide it by the standard deviation of x times the standard deviation of y. So we're taking our chameleon unit of measurement divided by the mice times chameleon. So chameleons again, and we get rid of that weird unit of measurement, and we're able to get a number between -1 and +1. So this gives a much more comparable unit of measurement, a much more easier to understand metric, especially when we're making comparisons in our data set, when we're communicating our results. Okay, so positive just represents to that it's a positive slope and negative is a negative slope. It doesn't really relate to the angle exactly. What it relates to is how close it is to 1 is going to be how tightly packed our x and y variables are on that line. The more spread out they are, the less correlation we have. But the more tightly packed, whatever the slope of the line is, the more closely packed they are to that line, the more or the higher closer to 1 we would have either +1, or if it's downward sloping we would be -1. Okay, this is again a much more easier way to communicate our results, especially when we're sharing our findings to people that are maybe not data scientists, or very likely lots of them will not be data scientists or even data analysts, or have really done a lot of studies in math. And so, but we still need to make sure that everyone understands what we're talking about. And correlation is a great metric for that.